We're starting our review for exam 2, and we're starting with rational expressions. So in number 1, we have a rational expression, and the instructions are to simplify this rational expression. So what we're going to do is factor out whatever we can from the numerator and denominator, and then simply cancel. So let's do that. From the numerator, I see we can factor out an x cubed. And in parentheses in the numerator, we're left with 25 minus 3x squared. And in the denominator, well, there's no factoring, we'll just write minus 5x squared. And then we divide. We can divide the x squared into the x cubed, and we're left with x. So we have x times 25 minus 3x squared divided by minus 5. Or you could multiply, you could leave it like that, or multiply through the numerator and get 25x minus 3x cubed divided by minus 5. And let me just caution you not to divide the 25 by this negative 5, because we can only divide the denominator into the entire numerator. We would do that only if the 5 divided into this coefficient as well, which it doesn't. So 5 does not divide into the entire numerator, so we're just going to leave it like this. And number 2, again, we want to simplify, and we're going to do this by factoring and seeing if we have any common factors. Let's factor that numerator. Signs are different because of the negative sign. And we want to get a minus 2 in the middle. Okay, we're going to try 5 times 3. And to get the minus 2 in the middle, it'll be a plus 2 and a minus 5. Just check that. We have minus 5x plus 2x is, sorry, this should be a 3 over here. Let me just fix that. 3 times minus 5 is minus 15, so now let's check that we get a minus 2x in the middle. So we have minus 5x plus 3x gives us that minus 2x. All right, now let's factor the denominator. Again, different signs because of the negative c value. All right, and 5 times 2 now will be the factors of 10, and we want to get a minus 3x in the middle. All right, so let's do a minus 5 and a plus 2. Just check that. Minus 5x plus 2x is a minus 3x. So we see we have a common factor of x minus 5. We can divide top and bottom by x minus 5, and the reduced expression is x plus 3 divided by x plus 2. Again, we want to simplify, and we'll factor numerator and denominator. So numerator, we have 2 plus x times 2 minus x. That's a difference of 2 squares over there. All right, and then the denominator, here we have x, again, different signs. We want to get a plus 2 in the middle, so we'll try 4 times 2. We'll try a plus 4 and a minus 2. Check that middle term, minus 2x plus 4x is a positive 2x. All right, now we see here we have a 2 minus x and an x minus 2. Because these are subtractions in different order, we can cancel, but we must replace with a minus 1. So the reduced expression is minus 1 times 2 plus x divided by x plus 4. In number 4, we're multiplying, but before we multiply, we want to reduce, just like we did in the previous examples. We want to factor whatever we can and cross off common factors. So let's see, here's something, sorry, this is the only thing we can factor right here, that denominator, that quadratic, and let's factor that now. Okay, 5 times 2 and we'll have a minus 5 and a plus 2. Check the middle term. 2x plus a minus 5x does give us that minus 3x. Here we can reduce right here, x minus 5x minus 5. We also can reduce here. We have a 10 and a 50. 10 divides into 55 times. And here we have an x and an x, which cancel out. So just see what's left. In the numerator, we're just left with 5. And in the denominator, we're left with x plus 2. So that's the reduced expression. In number 5, we're dividing two fractions, so we must take the reciprocal of the second fraction and change to multiplication. So we'll do that now. Change to multiplication and reciprocal. And now before we multiply, we're going to try to reduce. Factor and cross off common factors. 25 minus 9x squared, that's 5 minus 3x, times 5 plus 3x. This is a difference of two squares that we're factoring here, difference of two squares. Okay, so here we have 3x minus 5 and 5 minus 3x, subtractions in different orders, cancel and replace with a minus 1. We can reduce the 4 over 8 over here, just divide top and bottom by 4. And x over x squared, divide top and bottom by x. And we're left with a 2x in the denominator. So multiplying through the numerator, we just have minus 1 times 5 plus 3x. And in the denominator, we just have 2x. In number 6, we have a subtraction of fractions. So we're going to find a common denominator. Now, the two denominators do not have a factor in common, so the common denominator would just be the product of the two denominators. So let's do that. So we have 3 times x plus 2, and just write them as a product. Don't multiply out. All right, we have to change x over 3 to this to a fraction with this denominator, so we're going to multiply top and bottom by x plus 2. So in the numerator here, we have x plus 2 times x. In the second fraction, we have to multiply top and bottom by 3. So in the numerator here, we have 21. All right, so this numerator over here is multiplied through, it's x squared plus 2x. Okay, so let's just subtract those numerators. And we have x squared plus 2x minus 21. In number 7, we're adding 3 fractions, so we need common denominator. Let's look at these coefficients, 3, 4, and 12. The smallest number that all 3 divide into would be 12, so that will be part of the common denominator. And then we have x squared, x, and x take the largest power for the common denominator. So 12x squared is our common denominator. Actually, our least common denominator. We want to get an equivalent fraction with this denominator. So we have to multiply numerator and denominator by 4. All right, so we have a 28 here. The second fraction, we have to multiply numerator and denominator by 3x to get that 12x squared. Okay, so we're multiplying by 3x. So this numerator is 3x. And we have to multiply the last fraction, top and bottom, by x. So here we have 5x. Now let's add these fractions, put them over the common denominator of 12x squared. So we have 28 plus 3x plus 5x. That's 8x. And notice that we can reduce this. We can divide top and bottom by 4. All the coefficients are divisible by 4. So let's do that. Divide 12 by 4, and we have 3, so that's 3x squared. 28 divided by 4, that's 7. And 8 divided by 4 is 2, so here we have 2x. Alright, so this is reduced. Okay, here again, we're subtracting fractions, but notice we have a common denominator, 2x plus 5, 2x plus 5. So basically, we are just going to subtract the numerators. And we have to be careful with signs. Alright, so I'm just going to write down the first numerator, x squared minus 2x plus 4. And here's where we have to be careful. We're actually subtracting. I'm going to put in an extra step here. We're subtracting the entire numerator, 4 plus 2x minus 5x squared. So we have to be careful when we open parentheses. So let's open parentheses right now. It's as if we're multiplying through by a negative symbol. Minus 4 minus 2x. And here we have minus times minus is plus 5x squared. Alright, and now just add up the like terms. So x squared plus 5x squared, that's 6x squared. Minus 2x minus 2x, that's minus 4x. And 4, negative 4, well, those cancel out. And here's the result. In number 9, again, we want to add some fractions, and we want a common denominator. This time, we have a denominator that can factor, so before finding a common denominator, we're going to factor this denominator. This denominator is x times x minus 1. And here we have x squared. So we want a denominator that contains all the factors. That is, it'll contain factor x minus 1, and to the highest powers that they appear. So x appears to power 2 in the second denominator, so we're going to include x squared in our common denominator and x minus 1. So that'll be our least common denominator. It contains all the factors to their highest powers. Okay, so now to get an equivalent fraction, we have to multiply top and bottom by x. So here we have x times x plus 1. And here top and bottom by x minus 1. So here we have 5 times x minus 1. Let's just multiply out those numerators. Alright, so here we have x squared plus x multiplying through, and here 5x minus 5. So now we're ready to combine the numerators. X squared plus x plus 5x minus 5. So we just have two like terms over there in the numerator. We'll add those and we'll be done. Okay, so we have x squared plus 6x minus 5. In number 10, we have what we call a mixed quotient. That is a fraction that contains fractions within it. And what we want to do is simplify by getting rid of these denominators. And the way we'll do that is we'll multiply top and bottom by an expression that all the denominators divide into, it actually will be the least common denominator of these denominators, AB, B, and A. All right, so the least common denominator is AB. So we'll multiply top and bottom by AB. All right, so multiplying the numerator by AB over 1, and the denominator as well, multiplying by AB over 1. Okay, here these just cancel, and we have 5 in the numerator. In the denominator, I'm first going to do the distributive law, just placing this next to this and this next to this. And once I do that, now I'll cross off common factors. All right, so this B cancels with this B, and this A cancels with this A. And we see that we're left with 5 in the numerator and A squared plus B squared in the denominator. In number 11, we have another mixed quotient, and we want to eliminate these denominators, 8 and x squared. So we'll multiply top and bottom by an expression that both denominators go into, and that would be x squared. That would be the common denominator. So let's do that. So we have 4 minus 3 over x squared, 2 minus 1 over x, and we're multiplying top and bottom by x squared over 1. So first we'll just do the distributive law, multiplying through. Here we have 4x squared minus 3 over x squared times x squared over 1. And in the denominator, first we have 2x squared minus 1 over x times x squared over 1. So now we'll cancel in the second step, cross off this x squared with this one. And here, x divides into x squared, and we're left with x. Let's write what we have left. So here we have 4x squared in the numerator, minus 3. And in the denominator, we have 2x squared minus x. Okay, now we're going to start looking at radical expressions. So in number 12, we want the cube root of minus 27. So that would be minus 3, because minus 3 cubed just do minus 3 cubed, and here we have 9 times minus 3. Minus 3 cubed we see is equal to minus 27. So the cube root is minus 3. In number 13, we have an expression containing variables. We want the 6th root of x to the 12th times y to the 30th. So to take the 6th root of a power, we just divide the exponents by 6. So that would be, both exponents are divisible by 6, so that would be x to the 12 divided by 6, or x squared, and y to the 30 divided by 6, or y to the 5th. In number 14, we're asked to simplify this radical expression. Now, we're taking a 5th root, and notice that we have the power x to the 24, and 24 is not divisible by 5. So that's why we're simplifying, not evaluating, but simplifying. Okay, so what we're going to do is write x to the 24 as a product where one factor is a power whose exponent is a multiple of 5. So what we're going to do is find the largest power whose exponent is a multiple of 5. So just start counting down from 24 until you hit a multiple of 5. So the largest number, less than 24, that's a multiple of 5 is 20. All right, so we're going to factor this as x to the 20 times x to the fourth. And we'll take the fifth root of x to the 20 by dividing 20 by 5. 20 divided by 5, so we have x to the fourth is the fifth root of x to the 20th. So this simplifies to x to the fourth outside the root, and inside this fifth root, we still have that x to the fourth. So that's the simplification. In number 15, we're simplifying the fourth root of 162. So we want to factor 162 into factors where one factor is a fourth power. So let's just think of the fourth powers that we know. So first, 2 to the fourth is equal to 16. And 16 does not divide into 162 evenly. So let's try 3 to the fourth. 3 to the fourth, 3 times 3 is 9. Times 3 is 27. Times 3 is 81. And 81 times 2 is 162. So that's the factor we're looking for. And we're going to take the fourth root of 81. And we see over here that that's equal to 3. So this simplifies into 3 on the outside. And we have that 2 left underneath the fourth root.